Welcome to AI Frontiers, where cutting-edge artificial intelligence research is explored. Today's episode, titled AI's Safety Net, Governing Tomorrow's Intelligence, synthesizes 11 papers from July 13, 2025, focusing on innovations in safety, reasoning, and sustainability, with a spotlight on governance breakthroughs. Imagine artificial intelligence that reasons flawlessly while preserving the planet. That captures the thrill of these papers. This presentation explores the basics of the field, key themes, findings, methods, and standout studies. Insights on safe, smart machines that could reshape the world are presented. By the end, AI's promises and challenges will be viewed in a new light. The adventure spans from brakes on rogue AI to eco-friendly technology. The field of computer science, artificial intelligence, involves designing systems that mimic human intelligence for tasks such as learning and decision-making. Algorithms that adapt, predict, and solve real-world problems efficiently form its core. Impacts on daily life range from chatbots to medical diagnostics, driving innovation across sectors. Intersections with ethics and neuroscience address risks like bias or energy use. These 11 papers showcase the rapid evolution towards safer, more capable AI. A key research theme is AI safety and governance, focused on preventing risks through proactive controls. Barnett and colleagues propose tools such as hardware tracking to pause dangerous developments. This overlaps with global policies to avert misuse or loss of control. The technical concept of monitoring protocols involves simple checks to flag risky AI capabilities, ensuring safety. Support comes from Nazarov and colleagues' testing for interconnected AI systems. Another prominent theme is neuro-symbolic and hybrid reasoning, which merges brain-like networks with rule-based logic for reliable AI. Allen and colleagues integrate large language models into paraconsistent logic to handle contradictions effectively. This enhances tasks like fact-checking by boosting consistency and trustworthiness. The technical concept of paraconsistent logic allows reasoning with inconsistencies without system failure, akin to flexible decision-making. This theme builds on hybrids for adaptive, error-free reasoning in dynamic scenarios. Zhu and colleagues survey models that switch between quick and detailed thinking modes. Connections are made to Martirana and colleagues bridging bots for multimodal robot actions. Relevance lies in reducing errors in high-stakes areas such as healthcare or law. A third theme emphasizes sustainable and efficient AI, balancing innovation with environmental responsibility. Winsta reviews energy costs, e-waste, and compute inequalities in development. Wang and colleagues advance generative models for efficient offline reinforcement learning. The technical concept of reinforcement learning involves agents learning via rewards, like trial and error, but optimized for less data waste. Ties are made to Xiao and colleagues. Causality-informed anomaly detection for better efficiency. Key findings from these papers include several critical insights. Barnett and colleagues demonstrate that technical tools enable verifiable pauses on risky AI, averting potential catastrophes. Allen and colleagues show that neuro-symbolic hybrids achieve consistent reasoning, improving factuality in benchmarks. Xiao and colleagues reveal that causality boosts anomaly detection, yielding faster convergence and tighter error bounds. Zhu and colleagues find that adaptive models cut inference time and energy without losing performance. Winsta quantifies AI's hidden costs, like emissions and inequalities, calling for equitable green development. Methodologies across these papers highlight common techniques. Reinforcement learning allows agents to learn via rewards, as used by Xiao and colleagues for dynamic control. It is strong but data-intensive. Neuro-symbolic integration combines neural networks with logic, applied by Allen and colleagues for reliable reasoning, though compute-heavy. generative models create efficient plans, as optimized by Wang and colleagues for trajectories, powerful yet slow in sampling. Knowledge graphs structure data for audits, enabling transparent robot actions in Martirana and colleagues' work, but rigid in ambiguity. Spiking neural networks provide brain-like efficiency, used by Safa and colleagues for agent control, though challenging in training. The first selected research paper is Technical Requirements for Halting Dangerous AI Activities by Barnett and colleagues. It is chosen for its impactful blueprint on AI governance, addressing real-world risks innovatively. Objectives focus on providing tools for pausing hazardous AI to prevent misuse or loss of control. Methods include monitoring, verification, and enforcement via hardware and benchmarks. Findings enable global halts, reducing risks through verifiable safeguards. Significance lies in its seminal role for policy, bridging technology and ethics in AI safety. The second selected paper is Sound and Complete Neuro-Symbolic Reasoning with LLM-Grounded Interpretations by Allen and colleagues. It is chosen for its novel hybrid approach, representing advances in reliable reasoning directions. Objectives center on fusing large language models with logic to handle inconsistencies and ensure trustworthiness. Methods embed large language models in paraconsistent logic, tested on factuality benchmarks. Findings achieve high consistency, outperforming baselines in reasoning tasks. Significance is pivotal for error-free AI in critical fields like medicine. The third selected paper is The Hidden Costs of AI, a review of energy, e-waste, and inequality in model development by Winsta. It is picked for its representative focus on sustainability, highlighting ethical research directions. Objectives aim to expose environmental and social costs of AI development for better practices. Methods involve synthesis of studies quantifying emissions, waste, and compute gaps. Findings reveal massive footprints and inequalities. Advocating green metrics. Significance influences equitable AI, fostering inclusive and eco-friendly innovation. Future directions in AI research point toward integrating adaptive systems for multi-agent intelligence, building on Wang and colleagues' work. Green benchmarks are expected to be prioritized to reduce energy waste across models. Global cooperation for governance will be fostered, addressing compute divides. Causality in reinforcement learning will advance for scalable, black box-free solutions. Challenges like ethical scaling must be tackled to ensure human-compatible AI. This synthesis was created using AI tools, including GPT Grok, with model Grok 4.0709 for content generation. TTS synthesis was performed using OpenAI for audio narration. Image generation was handled using Google for visual elements. While the synthesized content underwent review by a human expert, it is important to acknowledge that some oversights may still exist. All references are provided. Subscribe to the YouTube channel for more cutting-edge AI research breakdowns. The channel is titled AI Frontiers. Its description invites viewers to dive into daily arXiv preprint server papers, exploring AI's future with expert insights. Hit subscribe and turn on notifications to never miss an episode. Join the community and share thoughts on these groundbreaking ideas. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.